was left as homework last week was this tableau, which was quite an easy exercise because you just had to do one pivot step. So if you've done it, you can check it. If you haven't, then you can't check it, obviously. Any questions or objections? Have I got it right? I might have got it wrong as well. Possible. Okay. And then the second thing that was left was this letter C. Has anybody done part C? You don't even see it? Anybody done part C? You probably haven't because that was a bit provocative. That was to make you think, because that's the topic of today. So, well, you could do it because it's kind of obvious what we're going to do today. So, everything is obvious. It all comes out of the tableau. What is what? Please, can we have a working atmosphere? I know it's close to Christmas and it's dark and everyone's bored and tired and sleepy and nobody wants to be here. It's the same for me. I don't want to be here. Do you think I want to be here? Oh, don't listen. No. But you see, it's not making it easier for me if people are chatting at the back and so on. And it's not just for me. It's also not making it easier for the rest of you if you're chatting at the back. Okay, enough plain talking. So you could get some marks anyway if you did one pivot step. And what we're going to do today is not these exercises, but we'll be using the same LP and the same final tableau to learn how to solve these exercises 1 and 2, and then 1 and 2 is left as homework. And so if you read the exercises, you can see that what I'm asking is something that is called an allowable range, but whatever it's called. The question is, how much can I wiggle with this right-hand side? That's the first question. So that this basis is still the feasible optimal basis. Okay. So now we know that. How do we know that this basis is feasible and optimal? How do we know that this basis is optimal? That's the one that we want. We know it because, yeah, please, anybody? Stop texting. So how do we know that? Well, we know that feasibility we know because of these values, there are no negative values. And optimality or dual feasibility we know because there are no negative values in the objective. For a maximization problem. For a minimization problem, it would be the opposite sign. Well, in the objective. So we have these two conditions. Everything non-negative in the val, other than the objective. The objective can be anything. And dual feasibility or optimality criterion, nothing negative in the objective except for and so these are the two important conditions. And I really question one, asks, what can we do with the right-hand side of the second constraint? How much can we change it so that both conditions remain satisfied? And the second question is, what can we do with the -5 in the objective function, the coefficient of x2, so that both conditions remain satisfied? Okay, and that's what we look. So this is, in some sense, when you're, as we were doing these exercises about how we're changing the right-hand side and how we're changing the objective, in some cases we didn't have to pivot, and the bases remained optimal. And in other cases, we did have to do either a prime or a dual pivot to get the optimal solution, the optimal solution. And this question really asks you, how much can we wiggle with the numbers in the formulation so that we wouldn't have to pivot? Okay, that's the same question. I said that I'm leaving these questions 1 and 2 as homework, but we'll do a couple of examples like this. Okay, part A. So we're starting with this this LP and this final tableau. Now the question is how much can B1, which is currently 15, so that's the right-hand side in the first constraint. How much can it change for the current basis to remain optimal, feasible and dual feasible? And that's a question. All right, is the question clear? So the way this is, we can approach this is we investigate what happens if B1 changes to 15, which is the current value, plus some delta. And delta is a variable, and we don't know its value, but we want to understand what happens in the tableau when we change B1 by an unknown amount of deltas. So what happens? Remember, from when we were doing changes in the right-hand side, what's going to happen to the tableau if we start changing the right-hand side of the first constraint? Where's it going to show? Okay, I'll tell you. Nobody wants to say anything. Okay, the only thing that's going to change is the value. You probably know that. And it's going to change by delta times the S1 column. Because that's what happened when we were changing the right-hand side. If we're changing the right-hand side of the first constraint, then the same amount that we change it by, so delta, the same multiple of this column is going to be added to this column. Okay, so that means that The val column changes. So what does it change to? Well, the first entry is going to be 3 plus delta, because there's 1 in the S1 column in the first row. What's the second entry going to be? Seven plus delta. I'm waiting. Just 7. Do you agree now? Yes, correct. Because there's a 0. So 7 plus 0 times delta. The third entry. Now that's what you were thinking. 7 plus delta. And the last entry, 34 plus 2 delta. Yeah. And everything else remains the same. So for this to still be optimal, what do we need? We need that 3 plus delta be greater than or equal to 0. And 7 should be greater than or equal to 0. And 7 plus delta should be greater than or equal to 0. And the last one, we don't care, because there's no constraint that says that the objective should be greater than or equal to 0. Okay, and this is equivalent to delta being greater than or equal to -3. This is true for all delta. And this happens if and only if delta is greater than or equal to -7. Thought she was texting, she's taking. Okay. So is there, for what values of delta are all these conditions satisfied? -3, yeah. Any other values? Or anything greater than -3 as well. So if I say delta from -3 or larger than -3, then the tableau is still feasible. Okay, and that satisfies the conditions. Therefore, tableau remains feasible for all delta greater than or equal to -3, which is the same as B1 greater than or equal to 12, I think. Okay, so what have we found? Jordan, what have we found? Yeah. Hmm? Can't hear you. Still can't hear you. It's my problem. But what we found is that we can change the right-hand side to this top one. Oh, put this back. So from that 15 to 12 or anything larger than 12, and it still remains feasible. That's the solution to that question. It shouldn't really say how much, it should really ask how can it change. So it can change to anything greater than or equal to 12 and the base is equal. Any questions? No. Time. So that's it. That's part A. Part B. Part B is how can the third constraint, the right-hand side in the third constraint change? Well, that's really an exercise. So you should be able to solve it now. Go ahead and solve it. Is there a way to move the wall forward so that it would isolate the back row? Okay. Have you got it? Do you know what to do? Try to do it.
That's not your right one. Oh.
Okay, what's the new valve? Most people got it. Anyone? 3 minus 3 delta.
7 plus delta.
7 plus delta.
7 minus 2 delta.
Yeah, 7 minus 2 delta, and which we don't really need for the answer, but it tells us how the objective is going to change if we wanted to know that. So now, of course, we need 3 minus 3 delta greater than or equal to 0, 7 plus delta greater than or equal to 0, 7 minus 2 delta greater than or equal to 0. We do this, solve for delta, so that delta is no more than 1. This says that delta is greater than or equal to minus 7. And this says that delta is less than or equal to 7, 2. Is that right? I'll check. It's okay. So basis, so the tableau, or the basis, by the way, remains feasible what? Everything good? So for what values of delta? I want an interval. Minus 7 to 1. Why not from minus 7 to 7 over 2?
It's still got a side to the top. And 1 is less than.
This is a smarter group than last year. Last year they just couldn't quite get which of these, which of the bounds to take. Yeah, so it has to satisfy all of them. It has to be above minus 7, it has to be below 1, and it has to be below 7 over 2. So the most constraining ones from the left is minus 7, well that's over 1, and from the right is 1. And we can give the range of the actual right-hand side now as well. And it was 4, wasn't it? So B3 will be from minus 3 to 5. Okay. This is sometimes called, in the wording of the question in the homework, This would be called the allowable range. It will be 3. Simple enough? Okay. Now, another simple question is question C. How can C1 change? I can see one change. That's quite a different question, isn't it? Because we're not changing the right-hand sides now, but we're changing the objective. But kind of similar because the objective is the right-hand sides in the dual, so doesn't really, it's not really very different. So say it changes to. So now it's going to be 7, which is the value we have, plus some delta again. And this is last week's topic, changing the objective. So what happened? We had 2 cases, do you remember that? 2 different cases of change. One of them was basic variables and the other one was for non-basic variables. C1 is the coefficient of x1. Is that a basic variable or a non-basic variable? If you say a random answer, then you have a 50% chance of getting it right. X1 is basic because it's in the basis. So that's the harder case. So let's start with the harder case. So if X1 changes, what we saw was that the objective row changes by the same multiple of the X1 row. That's what we did. 6 and 3/4 of a day. No, more than that. Okay, so the objective row changes to 34 plus 7 delta. So that's the val. X1, what's X1 going to be?
Just alpha.
No, X1 is the exception. That's going to be 0 because it's still in the basis. That's the odd one out. X2 now, yes. X3 stays 4, so that's quite simple. S1, 2 plus delta, correct. That's still on the screen. S2, yeah. S3, 1 minus 2 delta, correct. So what are the conditions for this to still be optimal or dual feasible? Zero is greater than or equal to 0, that's fine. 0 is greater than or equal to 0, that's fine. 4 is greater than or equal to 0, that's fine. 2 plus delta should be greater than or equal to 0. And 1 minus 2 delta should be greater than or equal. So now the rest is absolutely straightforward. So delta has to be greater than or equal to minus 2, and delta has to be less than or equal to 1/2. And we've got the answer. The tableau basis remains feasible for delta. What interval? Well, this one's very simple. It's minus 2 to 1/2. So C1 is in what interval? Five and 15/2. Thank you. Any questions? Everything's going brilliantly smoothly today. Hope it's going to be a smooth on the exam. Okay. The last possible thing that I can possibly ask is question D. Now, can I ask about C2? No, that's homework. So I have to ask about C3. Okay. So let's say that the new C3 is 1 plus delta. You know this is not really. So it's even more complicated. I'm making it more complicated than it is. So what's going to change in the tableau if I only change the coefficient of x3 in the objective? Anybody remember? I think I remember it. Just one entry.
Oh, is it four?
Four. How is it going to change? 4 plus delta? Yeah, right. So it's not going to make any sense. So this 4 becomes 4 plus delta. Which 4? Well, obj x3. I'll just write down more things. Only one entry changes. Okay. We know that. So the condition is that 4 plus delta should be non-negative, and that means that delta has to be at least minus 4. Hope. There's something wrong somewhere. Ah, I know what it's wrong. You misled me. Someone misled me. I can't remember who it was. That's good for you because it's not going to be 4 plus delta. It's going to be 4 minus delta. Because that's the way it is. Okay, so the remember this this bit in the tableau. There is MB inverse A. Yeah, oops. The top in the X's columns, and what's at the bottom is minus C plus CB MB inverse A. That's the formula. So when we change a non-basic coefficient, this minus C changes. This doesn't change. This only tells you that you take the basic variables coefficients and you multiply these rows by these coefficients and add them, and you get the last row. That's what this will mean. Because this matrix is this matrix which you have here. Multiplying by a row vector from the left means taking a linear combination of the row vectors of the rows. But you have to do minus C, and if you change T3 by delta, then this entry changes by minus delta because of that. Okay. So this is all wrong. But this is very good because like this, nobody's going to make that mistake ever. It's been made in the lecture. Very educational. Okay, so it actually changes to 4 minus delta. I was thinking about something strange. Okay, so we need that 4 minus delta should be greater than or equal to 0. So delta has to be less than or equal to 4. Okay, so current basis remains optimal. For delta less than or equal to 4, which is C3 is less than or equal to 5 because it's 1 in. If it was 1, we can add up to 4. That makes more sense. Okay. It makes more sense because when you look at the original problem, you're trying to maximize something, and then you would be increasing the objective coefficient of x3 any way you want. So it can't be true that. So at some point, because x3 is not in the basis, that's kind of like, it's not worth putting any positive value into x3. But if you increase the objective coefficient of x3 sufficiently, then it will be worth putting it into the basis and making it positive. So it should be an upper bound on the delta value for maximization problem, rather than the low bound as we got the first time round. That was looked fishy immediately. Okay. Now, so probably one last comment about this is that this 4 is called reduced costs of 3. So it gives you the interpretation of one last thing in the tableau. So how shall I put it? So these entries in the tableau for the decision variables, which are not in the basis, of course if they're in the basis they're zeros. And if they're not in the basis, they're called the reduced costs, and they give you immediately the information how much you would have to change, in this case increase because of maximization, how much you have to increase the coefficient in the objective of that variable for it to enter the basis. So if you're thinking about some kind of producing what's just sets, and you've got a decision variable which is not in the basis, then you know this reduced cost tells you how much you need to increase. Or even a better example, perhaps, is you're thinking about selling some intermediate product. You're not selling any; it's not in the basis. So you find the reduced cost of the intermediate product, and then that's the amount that you have to increase the cost, the price, the selling price of the intermediate product from the assignment to get some sales of that. Now that's linked to the assignment. Start living that. Any questions? We've pretty much covered everything in changing things post-optimality. The only thing we didn't do is how we change. What happens if we change these numbers? Yeah, but that's not so interesting, so we won't do it. I mean, it is interesting, but not time for everything. And we've got this homework for next week, and then for next week we'll remember in the beginning I was talking about duality and that the objective of the dual and the primal has the same value in the optimal solution. So we'll try to prove that theorem next week. That's it for now. Thank you.